Okay, so next session. So anyone who doesn't know me, I briefly introduce myself at the end. I'm one of the applications engineering specialists in the UK branch. So I tend to work with pretty much any customers throughout the northern region of Europe, and tend to work on test-focused applications, doing LabVIEW, test and PXI, and trying to help them get the best out of the tools. So this presentation kind of came about because, well, partly because I really wanted to go to the CLA summit and I needed to make a presentation up, but also because I kind of got to a point in my LabVIEW development where I wanted to develop further and learn more tools, but found that I'd done kind of all the training courses, I'd passed the architect exam, and there isn't any more kind of official training at that point. So I started trying to read books and learn a bit more around general software engineering. So that's where I came across this idea of assertions. So I'll explain a little bit more in a second about what they are and where I came across them. But in terms of what I'm going to go through in this session, let's say what are assertions, when, how to use them, and when not to use them. And then I've built up a toolkit in LabVIEW to try and help enable them. And so I'll give a quick demo of that, and then just show you where you can get the toolkit if you want to have a play around with it. So this book, Code Complete, it's by a guy called Steve McConnell, and it's kind of a software development Bible, I guess, in a lot of ways. When I gave this presentation in Rome at the CLA summit, I asked who in the room had read this book, and about, I think there's 112 architects in the room, probably half of them stuck their hand up and said they'd read this book. So it's kind of a very well-known and well-regarded book for good software development practices. The idea that I was kind of looking at with this was, well, one of the best explanations I've come across is if you've got a large application with lots of different processes, lots of different sub-VIs that you're developing separately, as you develop all of these sub-functions or sub-VIs in LabVIEW, the likelihood is that you'll develop a sub-VI, you'll test that sub-VI for certain functionality, and then you'll kind of basically decide that it's working to a set of specifications, and then you'll go away and develop other bits of the code, and you'll kind of forget about it. So if you put these assert value or assert bits of code within your application, then you can just leave them there, forget about them effectively, and basically say, if this sub-VI continues to perform to the specification, then the asserts will never do anything. If, say, 2 or 3 months down the line after you've developed a piece of code, you find that one of those asserts fails, it's because your code has gone into some corner case that you hadn't taken account of, and therefore it will loudly assert and kind of flag up an error or a dialog box or write a report or something to tell you this piece of code is actually has a bug in it and you need to sort that out. One of the other big points about them is that asserts should be compiled out of the code for deployment. So once you have finished your application and you know that it works and that none of these asserts are triggering, you can then just compile them out of the code for deployment so that your code hopefully runs a little bit faster. So that's kind of quite a long-winded way of saying it. There's a good Wikipedia article on asserts or assertions, which basically gives that in a bit more of a concise manner. It says here that typically causes the execution to abort. The consensus when I talked to the CLAs about this was that having the application aborting was maybe a bit drastic, and just writing a report or something saying where the asserts had failed was probably a bit more sort of conducive to good LabVIEW development and not just getting annoyed with the assertions and ditching them. So I've left the ability to abort the application on an assert if you want to, but most of the time you just do it just generates a report. So in terms of how to use them, The general rule, according to the book, is use error handling for conditions that you expect to occur, and assertions for conditions that should never occur. So the assertions are there for debugging and improving the code before deployment. So things like checking that the inputs and output parameters for a sub-VI are within expected ranges, a file is open or closed when a certain operation begins, file is read-only, write-only, lots of things like that, that if that case isn't true, then there's something wrong with the code rather than the user has done something wrong. Possibly more importantly, when not to use them is basically error handling. So if the user selects an invalid configuration file or tries to select an invalid hardware reference, that's the user's done something wrong, which potentially you could put some kind of safe or some code in the application to stop that happening, but essentially the user's done something wrong rather than there being a bug in your code. So that should be handled by general error handling, which should be in any good, well-written application anyway. So what I wanted to do was develop an API which allowed people to configure and build these assert functions and drop them into LabVIEW applications, and then as the application executes, it kind of logs all these asserts, and then if one of them fails, then it generates a report. So try not to jog this too much. So this VI that I've got in front of me here is what's called the do assert VI. So this is the actual VI that gets dropped down in the LabVIEW application in lots of different places to determine all the asserts. So the assertions, these two controls here are the kind of key to configuring an assertion. So we've got an assertion name, so you can have lots of different assertions with lots of different names, and then the assertion data. I've made that into a variant data type, so you can just wire any other data type into it, and you can basically reconfigure it to work with lots of different data types. So far, in terms of actually flagging up assertions, there's only a few data types that I've supported. So string, floating point doubles, I32s, and booleans. But if you wanted to sort of modify the toolkit so you had classes or I16s or I64s, then it's not a big modification. It's just I couldn't take account of every single data type that could potentially be wired into it. This around the edge here, we've got a conditional disable structure. So that means that in any given project, you can set a conditional disable flag and basically enable or disable all of the assertions throughout the application with that one flag. And then if you build an executable based on that, then they'll either be compiled in or out, depending on what that flag's set to. And then, where's my cursor gone? So that's all of that information is bundled together here, and then chucked into a queue, which goes over to an application, kind of what's called an assertion manager, which is just a queued message handler application that sits there and waits for all this information to go into it. So this is actually a slightly old version of the VI. I'll show you the new version, which has just got a few more bits and pieces in it in a second. So that VI that I showed you just there is what's contained in these two small sub-VIs here. So you can see I've got one where I've got a double floating point number, one with an I32 wired into it. Oops, didn't want to do that. And then I've also created another couple of VIs here, which basically configure and set up the assertions. So one of those is called the Preloader Search string. So you can preload a load of these asserts into the assertion manager application and then initialize them with certain values. And that means if you set up a load of assertion tests with this, where's my cursor gone again? This VI in the middle here, this is setting up the assertion tests with with basically a string that's passed down. So and within that string, you can say if this test passes it, or if this assertion is above this value and this assertion is above a different value, then fail the test or then pass the test. So you can combine lots of different assertions to get quite complicated algorithms that pass or fail the assertions. So the reason for the preloader search function is so that if you have some of those initialized or some of those, one of those algorithms generated, and you only sort of have a valid value for one of them, then you could fail an assert before you've really got going. So therefore, I've just kind of put that into, so you can initialize them to a value that won't make the assert fail. I've actually combined these two values, or these two sub-VIs here, into one sub-VI now, so it's a little bit neater. So I'll show you how that works in a second. And then in terms of the default output, this is the report that gets generated now. So it's a pretty simple report, just using the LabVIEW report generation toolkit. At the top there, we've got the assert string that tells you. So this is the name of the test, test 1 here. And then dbl_assert is the name of the assert. And we're just saying if dbl_assert is less than 100, then it passes. If not, if it's over 100, then it fails. And then you can put a comment in here as well to just, it basically ignores everything after the double / so you can sort of put any information in there as you want to. And then at the end of the string, there's an options string where I can actually, it ignores everything after the double / I should say, until it sees this options string bit at the end. If it sees that, then it looks at that, and that's where you can configure whether it aborts or generates a report or does some other things. Then we've got a picture of the front panel of the assert VI, just so you can see what values are in there. And then we've got the call stack here as well. Asynchronous messages was based on some feedback from, I think it was James Powell or Stephen Mercer. I think it was James Powell at the CLA Summit, who had the idea that if you have a large application, you're probably going to have lots of different asynchronous processes going on, and they're all going to be communicating with each other. It could be with the Act framework, it could be with some other Kube message handler or something. And you might have found that one of these sort of processes it works perfectly well on its own, but then when combined with messages coming from all of these other ones, that's what puts it into kind of an error state. So it might be important to log what those asynchronous messages are. So that's why I've got a section for asynchronous messages in here, which at the moment I'm still trying to figure out how to get that fully working. But the idea is it will log the last 10 or 100 or so asynchronous messages and then just give you that out as a set of strings, so you can go through and debug that. So before I talk about the GitHub, I'll just show you how it works. So along with, well, from that GitHub link, which I'll go back to in a second, you can download a VI package. If you install the VI package, then it will install this example along with the actual toolkit itself. So it's a very simple example. If I just open it up here, there's quite a lot of comments on here. So this is just an image of what the block diagram should look like once you've configured the example. And then down at the bottom, there's a ton of a big long comment there, which is basically information on how to run the example and how to use it. Let me just copy that string because that's important for a minute. In a minute. So what I decided to do, try and make this a bit sort of easier to understand and a bit easy to use, is start playing around with quick drop shortcuts. So if I go into Control Space and then Control A, I've got a LabVIEW VI that comes up here. And so this is my quick drop shortcut. So I've just got a couple of options over there on the left-hand side. define an assert variable or define a new test. So if I say I want to define a new variable called dbl_assert, spell that right, hit enter, and then it scripts a new VI, which is a new instance of this assert VI with the actual, let me just bring up the context cell. So it's got that assert name built into the VI, and then I can just wire that in, and that's all I need to do to define that new assert. And then I'll just do another one for the I32 assert. Trying to be very careful here not to knock my laptop over and pull the projector down. And then the other part was to define the assert test. So if I don't want to do that, pressing the wrong things. Going quick drop again. And this is where you can define tests. So again, there's some instructions over on the right here about how to actually define the tests. One thing that I was thinking about is the fact that if you've got a large application, then you're going to have had lots of different asserts throughout lots of different sub-VIs. And initially I was just pulling all of the asserts from the current VI and populating this list box down here. So you can use that to define your your sort of strings to set up tests. So that's what this bookmark here with the hashtag asserts is for. And that just means that as well as looking for actual asserts on this plot diagram here, it's going to pull all of this string out of here and populate the list with those asserts as well. So it's kind of I've tried to make it a little bit like intelligent about how it does it. So I can say test1 equals test, open brackets, and then if I want, I can basically select one of these asserts. So dbl_asserts selected. If I hit Control Enter, then it adds that in, and then I can just say it's less than 100, and then I can put in and or operator, so I can put multiple asserts within the same string. So you can define quite a lot of stuff in there. What I'll do is just do quickly is just copy and paste the string in from the block diagram. Hit enter, and again it's just scripted a new VI, which has got those asserts built into it. And then I just want to wire up this preloader search string here, which is an optional input. That just loads those asserts into memory. If you don't have that string connected, then it will load them in the first time you use it. It's just that would be useful if you had more complex testing. So if I run that, let's just so the test was, or one of the tests for the dbl_assert was if that test is if that value ever goes over 100, then it flags an assert. And what I'm doing to generate the number is just take a random number between 0 and 1, multiply it by y. So at the moment I've got it set to 100, so it's never going to fail. If I set that to 1,000, then fairly quickly it's going to trigger the assert, which is this directory here, and you can see that's filling up with more and more reports there. So if I just stop that, and then open up one of these reports, and you can see that's got all that information in that I showed you on the slide a minute ago.
If that takes a screenshot, it's cool.
Yeah, I need to. That's actually a small bug because I wanted to, rather than have the screenshot of the assert VI, I wanted it to be a screenshot of this main VI to show what the state of information there was. So I need to put something in to say this VI's caller or something. But there's quite a large call chain, so and it kind of gets long and short depending on where the VI is being called from. So trying to get the right VI reference is a bit tricky. And that's what's the problem with the asynchronous message VIs. Because one of the other things I've built is an add-on to the Act framework, which adds into one of the Act framework VIs a thing that includes a message into a buffer from the receive message function. But again, I was having problems with that yesterday, where it was getting the wrong VI reference.
Was it all text-based inputs, or could you almost put in a LabVIEW case structure where the default would be the assertion and all the other numbers will want you?
At the moment, it's just that I've only got that text-based string input, but there's nothing to stop you expanding it. I've left all the VIs open completely, no passwords or anything. So if anyone wants to improve the performance or make it more usable or anything, then I'm happy for people to play around.
Yeah, the script that you've got.
Yeah, that was quite fun actually, building those. Discovered a couple of undocumented features in LabVIEW along the way.
Only a couple?
Only a couple, yeah. Such as, yesterday I discovered another one, which was LabVIEW 2015. If you press block diagram cleanup on the receive message VI NAC framework, it crashes LabVIEW. It's great.
I like you for that feature.
Yeah, undocumented feature. But yeah, if anyone wants to download it and play around with it, I'll put it up on GitHub. I know Richard Thomas has been playing around with it and doing things with it as well. I don't know how to determine how many people download it. I know a few people who download it and play around with it a bit.
It shouldn't be a thing on GitHub.
It probably should, but I just haven't looked that hard.
Yeah. See, I was just actually going to ask a question about GitHub. Is there a lot of LabVIEW stuff on there? Because I know it's obviously the main place
more.
Yeah. I know it's like the main place for stuff like kind of open sourcing your projects.
The last 6 months I've seen a massive.
I don't know.
Yeah. We moved all our stuff over to it, probably.
Which Wi-Fi?
It's the top one.
Yeah, because that's like just kind of the conversation we were on earlier about kind of networking with people in web as well. It's another way to do it. So kind of find people. I don't know what easy it is to search, but kind of find people on there and be like, "You're in London. Yeah, I'm chatting this about LabVIEW."
Yeah, that's true. I've not read it.
I guess maybe it's worth opening it up and see if there's any questions from the web.
Yeah.
Peter, I was actually wondering, relating to the distribution method of the toolkit, it seems like a very useful toolkit. Will it be part of the VIPM? Like if I open VIPM, is it in that list there?
It's not. I've made it into a VI package, but I haven't actually published the repository so the VI package manager automatically picks it up. But you can install it with VI package manager. You just need to download the package
from here. Yeah.
Make sure not VPN.
Anything on Twitter.
See how many people have downloaded it.
Should I get your slide up about the kind of future topics?
Yeah.
Is there any questions from the web at all?
No, not at the moment. If anybody has any questions on the web, now is a good time to ask.
Cool. We'll come back to it. Thanks.
Thanks, Steve.